Imagine writing a letter, not to a friend, but to the universe itself. You have one chance to capture who we are, our hopes, our science, our art. This is not fiction. It's the true story of a message in a bottle. The golden record, sent across the vast ocean of space. A greeting from Earth, launched aboard Voyager 1, a machine built by human hands destined for the stars. On its side, a golden phonograph record holds the sights and sounds of our world. Greetings in 55 languages, music from Bach to Chuck Berry, images of our planet and people. It's a time capsule, a portrait of humanity in the late 20th century, drifting in the interstellar void. The decision to send this message was an act of optimism, a declaration that we are curious, that we wonder if we are alone. The golden record is more than data, it's a piece of our collective soul. Voyager 1 now travels beyond our solar system, a silent ambassador carrying the story of a world it will never see again. Its journey is a testament to our desire to connect. Today, Voyager 1 is farther from Earth than any human-made object in history. It is a silent witness in the cold, empty space between the stars. The message it carries may never be found, but sending it changed us. It forced us to reflect on our place in the universe, to distill our existence into a single story. As Voyager continues its trek, the data it sends back may hold a different kind of message, one we are only now learning to read. The golden record is our introduction, our hope, and our question to the cosmos, and its journey continues, carrying our story into the unknown. Voyager 1's story began with a rare planetary alignment in 1977, a chance to visit the giant outer planets using gravity as a slingshot. Its mission explored Jupiter and Saturn, revealing their storms, rings, and mysterious moons. At Jupiter, Voyager 1 captured the Great Red Spot and discovered volcanic activity on Io. At Saturn, it unveiled the complexity of the rings and studied Titan's thick, hazy atmosphere. After Saturn, Voyager 1's planetary mission ended, but its journey did not. Flung out of the solar system's plane, it set course for interstellar space. Decades later, in 2012, Voyager 1 became the first human-made object to enter interstellar space. Now, over 24 billion kilometers from home, it sends faint signals back to Earth. Its power fades, but it remains our only direct probe of the interstellar medium. Voyager measures cosmic rays and magnetic fields beyond the sun's protective bubble. It is a fragile link to a distant pioneer, a testament to human ambition. Voyager 1's data is a faint stream of radio waves from a place we've never been. For decades, its sensors have recorded subtle shifts in particles and magnetic fields, received by the Deep Space Network. But understanding this data is a challenge. The universe doesn't speak our language. Imagine trying to understand the ocean by listening to a single seashell. You hear a whisper, but miss the currents and life beneath. Voyager's data is similar, a one-dimensional stream representing a complex, multi-dimensional environment. Scientists sift through mountains of numbers, searching for patterns and anomalies, signatures of cosmic phenomena. The sheer volume and complexity are daunting. Hidden patterns may have gone unnoticed for decades. Our brains are wired for certain patterns, but the universe may operate on principles we can't intuitively grasp. Traditional methods, graphs, statistics, theories, may miss signals that don't fit our expectations. The challenge isn't just finding a needle in a haystack, but a needle we don't know how to recognize. To truly see what's there, we need new tools and new ways of thinking. The next step, a new kind of mind to help us look at the data differently. The universe's secrets may be hidden in the data, waiting for us to learn how to listen. The question is, are we ready to hear what Voyager is telling us? To unlock Voyager's secrets, scientists are turning to artificial intelligence. Machine learning excels at analyzing vast data sets and finding patterns invisible to humans. AI doesn't tire or bring bias. It searches for structure in the raw numbers, flagging anything that stands out. Scientists train AI on decades of Voyager data, teaching it what normal looks like in interstellar space. Once it learns the baseline, AI hunts for anomalies, spikes, dips, or repeating sequences that defy the pattern. This approach has already uncovered exoplanets and gravitational waves in other missions. Now, AI is focused on Voyager's whispers, hoping to reveal overlooked interactions or unknown phenomena. AI isn't replacing scientists. It's augmenting them, pointing to clues for human experts to investigate. The partnership allows us to ask bigger questions and search for fainter signals. With AI, we can push the boundaries of discovery from a mission launched nearly 50 years ago. The digital detective is on the case, searching for the extraordinary in the ordinary. What might it find, hidden in the static of the stars? Even AI has limits. Some patterns in Voyager's data may be too complex for classical computers. The universe runs on quantum mechanics, probability, superposition, entanglement. To truly understand it, we may need quantum computers, and with them, quantum AI. Quantum computers use qubits, exploring many possibilities at once, offering exponential speedups for certain problems. Quantum AI could analyze Voyager's data in fundamentally new ways. Finding correlations among hundreds of variables at once, it could spot faint, repeating patterns hidden beneath years of noise, signals we wouldn't know to look for. This technology is young, but progress is rapid. As quantum AI matures, it could reveal a richness in the interstellar medium we've only glimpsed. The next leap in discovery may be just around the corner. Imagine scientists using quantum AI to reanalyze Voyager's entire dataset, searching for evidence of artificial structures. The AI flags a series of faint, repeating signals as Voyager nears the Oort cloud, a vast, unseen shell of icy bodies at the edge of our solar system. These signals aren't random, nor from the spacecraft or known natural phenomena. The pattern is complex, mathematical, hallmarks of something constructed. The AI suggests Voyager's radio waves may have bounced off a nearby object, not a simple rock or ice ball. The object appears large, kilometers across, absorbing and reflecting frequencies in a structured way. Finding any object in the Oort cloud would be historic. Finding one that seems artificial would be world-changing. This isn't a flying saucer, it's something subtler, perhaps ancient, a probe, a marker, or dormant technology from another intelligence. The AI hasn't found a message, but an echo, an object with non-random geometry and material composition. It's a clue, not a conclusion, a breadcrumb trail into the darkness of our own backyard. The digital detective has found the anomaly. Now, understanding it falls to us. The path forward is uncertain, but the discovery would redefine our place in the cosmos. The Oort cloud may hold more than icy bodies. It may hold a secret from another civilization. The search for meaning begins with a single, unexplained signal. What story does this echo tell, and are we ready to listen? An AI's discovery is just the beginning. The claim of an artificial object in the Oort cloud would demand extraordinary evidence. Scientists would first try to prove the AI wrong, ruling out every natural explanation: plasma, sensor error, cosmic echoes. Teams worldwide would re-examine Voyager's data, scrutinizing every detail. Earth-based telescopes would listen for ongoing signals from the same region. Only if all natural explanations fail would the case for artificial origin grow. Even then, the conclusion would be cautious: an object with properties inconsistent with known natural phenomena. Definitive proof would require a new mission to see the object up close, a mystery waiting for a future explorer. Confirming an artificial object in our solar system would change everything. It wouldn't be a dramatic first contact, but the discovery of a footprint on a shore we thought was empty. This revelation would ripple through science, religion, philosophy, and art. Our history and conflicts would seem small. We'd see ourselves as inhabitants of a single island in a vast ocean. A new era of global cooperation would dawn, united by the quest to reach the Oort cloud. The mission would become humanity's greatest scientific project, requiring worldwide collaboration. We'd gain cosmic humility, realizing we're newcomers in a universe that's hosted intelligence for eons. The discovery could be frightening but also inspiring, a sign that survival on a cosmic scale is possible. It would give us a new story, not just who we are, but what we might become. The age of cosmic discovery would truly begin. We began with a message in a bottle, the golden record, Voyager's greeting to the stars. For nearly 50 years, Voyager has been our silent ambassador, sending whispers from the edge of the unknown. Its data is a treasure trove, hiding secrets too complex for human eyes, until now. With AI and quantum tools, we're learning to listen in new ways, searching for echoes we never expected. If we find an anomaly, an echo from something ancient and unknown, the journey of discovery will only begin. The burden of proof will be immense, but the impact could unite humanity in a shared cosmic story. Perhaps the reply to our message is already here, waiting in the data. The final question: if we find something, are we ready for the answer?